Meiden assistance dog robot technical demonstration video. I will talk about the current state of guide dogs for the blind. It costs about 2 to 3 million yen per dog to train one. Guide dogs that are no longer able to work are taken in and spend the rest of their lives with volunteer families. We wanted to do something about this situation, so we came up with our team's performance idea. Our performance theme is Assistance Dog Robot Saving the World with robots that help people. In Japan, braille blocks are installed for the visually impaired. There are two types of braille blocks, guiding blocks and warning blocks. Performance contents. The assistance dog robot recognizes braille blocks and guides the visually impaired. Stops when pedestrian pass. Checks pedestrian signal and cross at crosswalk. This is a diagram of our robot. These are our robot's performance features. First, pedestrian signal recognition using AI cameras. Second, pedestrian signal electronic circuitry. Third, assistance dog robot braille blocks recognition. Fourth, robot-to-robot collaboration program. These are images of the AI camera. We used it on M5 stick. The connection between the AI camera and the LEGO Spike hub was made by modifying the electronic circuitry of the LEGO Spike ultrasonic sensor. Pedestrian signal recognition using AI cameras. Pictures taken of pedestrian signal are stored in the AI camera as class X. When the AI camera sees pedestrian signal, it sends an electronic signal to LEGO Spike, but it is first converted into a LEGO Spike recognizable signal by the ultrasonic sensor. This is the internal structure of the sensor robot. The motor used is a LEGO Spike air motor. We increase the rotational torque by combining multiple gears, allowing it to move the heavy suitcase more easily. This slide shows the parts improved during the production process. At first, the braille blocks were detected using only 3 touch sensors, but with 3 touch sensors, it was not possible to distinguish when the assistance dog robot wandered off of the braille blocks. To solve this, we added 2 color sensors, which then enabled the system to identify those transition areas well. This is a demonstration video showing how the sensors work. The color sensors are programmed to respond to the color black. If the sensor on the left detects black, the system corrects by turning right. If the color sensor on the right detects black, it corrects by turning left. Otherwise, it continues to move straight. In this way, assistance dog robot stays on the braille blocks. Future technological development of the assistance dog robot. Currently, the robot reads braille blocks using touch sensors and color sensors. However, in the future, we aim to incorporate infrared sensors, similar to those used in actual suitcase-type robots, so that the robot can detect surrounding walls and obstacles, avoid them, and navigate more smoothly. Electronic circuit and mechanism of the pedestrian signal robot. Circuitry. We use 17 LEDs for the pedestrian signal robot. We designed the soldering components ourselves, including the use of resistors to adjust the voltage. Mechanism. An ultrasensor detects people trying to cross the pedestrian crossing and transmits the information to the pedestrian signal robot via Bluetooth. Upon receiving the signal, the LEGO Spike M motor is programmed to control the pedestrian signal robot. Pedestrian signal program and demonstration. Danger detection system. AI camera robot. 1. Ultrasonic sensor detect passing people. 2. Lowers flag to signal danger. Sensor robot. 3. Stops moving. This is a demonstration of how the robot reacts when a pedestrian is detected. Once the sensor robot detects a running block, it transmits this information via Bluetooth to the AI camera. Upon receiving this signal, the AI camera rotates to look for a pedestrian signal. The AI camera rotates to search for a pedestrian signal, and it adds the rotation angle to a variable that is sent to the sensor robot. When the signal is received, the AI camera sends the value of the variable, which shows how much it has rotated to send the signal to the sensor robot. Using this information, the sensor robot calculates how many degrees it needs to turn from its current angle to face the crosswalk, and then it rotates accordingly. Determines whether the pedestrian signal is red or green. When the pedestrian signal turns green, the AI camera sends a message to the sensor robot telling it that it's safe to process. When the AI camera recognizes a green pedestrian signal, it determines the angle it needs to turn to face the pedestrian signal, and the assistance to robot then rotates by the amount. Thank you for your attention. We look forward to seeing you at our performance.